Hi everyone, welcome back. In the last couple of videos, we looked at how we can use KFold cross-validation and also hyperparameter tuning for traditional scikit-learn models, support vector machines or random forest or any other traditional machine learning model. Now in this video and in the next one, let's see how pretty much the same concept can be applied for keras-based models for neural networks. And the reason why I'm separating these two is, of course, the KFold cross-validation and grid search tools are available as part of your scikit-learn package. So typically, you would think that they do not play very nice with neural networks that comes from a different framework like Keras and TensorFlow. But luckily, it allows us to work with them, and that's the whole point of this video. And again, if you haven't subscribed to this channel yet, this is a great time to do that. And of course, while you're there, look for this little thanks button and show your generosity. Okay, let's jump into today's plan in this video. And we are going to learn about a few things, but I want you to have some background in terms of what we're going to do, so your time is worthwhile. Okay, KFold model. It's a model validation technique. Sorry, KFold cross-validation is a model validation technique. And again, I hope you watched my last 3 videos, in which case you'll find the next 1 minute to be boring. But if you haven't, then at least you're on the same page as the others who have who did indeed watch those videos. Okay, so KFold, again, we are not trying to train a model and get the best model. We are actually evaluating different models and trying to find the best model or best parameters. And it's cross-validation between multiple folds. So you're dividing your data into different number of folds, and you're presenting the same data in different ways, in multiple ways, to the training and the testing part of whatever the model that you're trying to evaluate. And in scikit-learn, the KFold library provides you both the training and testing indices, so you can split the data randomly, sequentially. But if by default, it's without the shuffling, but you can shuffle the data and then split the data into multiple folds. And as I mentioned, it divides the data into K folds, as the name suggests. K is the number of folds that you want to divide your data into. So if you have 500 data points, and if your K equals to 10, then in each data point you have 500 divided by 10, right? So that many data points. And one group is used for testing. So if you have, again, going back to the 500 example, so if you have 500 divided by 10, so let's say you have 50 per each fold, one of the 50 is used for testing and the remaining is used for training. And all combinations are used for cross-validation. And normally we would use cross-validation score in scikit to evaluate the model. Traditional models like support vector machines, random forest, gradient boosting, etc., but not the deep learning models. I already mentioned that, and that is exactly what we are going to cover as part of this tutorial. We'll find a way to make our Keras model available to the cross-validation score function, so you don't have to manually enumerate, but we'll go through both processes. And the dataset that I'm going to use, you can access via this link. I'll also leave the link as part of the description. And it's basically a tabular data where you have multiple features of interest and one output with binary output, basically malignant or benign, based on multiple features. Okay, with that information, let's go ahead and jump into the code. And many of you ask me like what IDE I use. This is nothing special. This is basically the Spider IDE that comes as part of your Anaconda installation. And I love this because it makes it easy for me to visualize variables and plots on the top right-hand side right there as I'm going through the code. So it's a great tool for teaching next to the, of course, notebooks. I'm not a big fan of notebooks, but again, notebooks allows you to add text and make the communication easy. But this is when it comes to IDEs, and if you're into training, this is or teaching, the new coders, this is a great IDE. Okay, so let's go ahead and start by understanding what Python version I have. I'm working with, I believe it's 3.7, but let's go ahead and print that Python version. It's 3.7.11. Okay, so that's the version I'm using. And we will be working with scikit-learn and TensorFlow, Keras as part of TensorFlow. So let me go ahead and spit out the versions of that. So scikit-learn is 1.0.1. And let's import TensorFlow. Takes a second because this is the first time I'm running it in this console. So yeah, my TensorFlow version is 2.4.4. Okay, so with that information, let's jump in. First of all, let's understand the data. This is exactly the same data we looked at in the last video, so I will not spend a lot of time, but let me explain that we are importing a couple of plotting libraries and pandas so we can capture the CSV file, the data that comes in CSV file, into a pandas data frame. And from TensorFlow.keras, I'm going to import sequential, dense, activation, and dropout, because in this specific file, I'm going to show you how we normally work on this problem. And I'll switch to a different file where we are manually enumerating each fold. And then in another file, I'm going to show you how everything can be easily done using our KerasValScore method. And I'll share all of these. Look for the GitHub link and under the description down below. Okay, so because we are going to put together our model, we need Keras model, we need all the required layers right there, and that's what we are importing. Okay, it's time to import the data set. And again, this is basically a CSV file with a bunch of columns, I believe about 30 columns, and 29 of them are used for training, and one is used, well, that's the prediction, that's your Y values. So I'm capturing that as part of my data frame. Again, in case you haven't watched my previous video, let me quickly open that to show you that, okay, the ID column is just an ID. We are going to ignore that. The diagnosis column, we are going to rename this as label because it is the label, and it's got two types of label. One is B and the other one is M. B stands for benign, M stands for malignant. And in traditional machine learning, last couple of videos, we did not change these values to any encode. We did not encode them, basically. We didn't encode them to zeros and ones. We just left it as B and M because the traditional machine learnings, like support vector machine, for example, that can easily handle these non-integer labels. But now, because we're talking about Keras, we need to take care of that. Just a quick note. Okay, all these other attributes, I mean, for example, it says mean radius and mean texture. So these are all various features, attributes that have been measured from whatever this tumor or whatever that thing was. So these are all various features or attributes that we need to fit to predict this diagnosis column. Okay, so that's enough information about it, and you can basically go ahead and print out a couple of aspects. For example, right there, it just shows you, okay, these are all the various aspects, features that we have, about 30 of them, 31, but I would say the ID column is useless, and the Y column, the diagnosis column, is also not used as part of our machine learning fitting. So that's our Y anyway. Okay, so now let's look at is null, like is there any values that need to be taken care of? No, so we're not worried about dropping any rows where we have null values. And the first thing, like I mentioned, I'm going to rename diagnosis into label because it's easy for me to say label than diagnosis every time. And you can also look at the data types, and the data type tells you all the values are float64 except for the label, which is an object because it's either B or an M, right? So we need to take care of that. So okay, this is not replace categorical values with numbers. This is just a different way of looking at well, let's go ahead and print this out. Why comment it? So here it basically tells us that, okay, we have 357 benign and 212 data points that represent malignant. They are unbalanced, of course. I have almost 1.5 times B compared to M. So you can try any techniques for balancing your data sets. Again, look at my video on that specific topic. Okay, I did not comment that, but I want to move this close to understanding the data. Now let's define our X and Y. So my Y is basically the label column, and my X is every other column other than the ID and label, so which we'll define in a second. But Y is basically B or M, so we need to convert that into integer encoding. So let's change that to zeros and ones, and you probably know how to do that. As part of scikit-learn processing, you have label encoder, and I am fitting the label encoder and transforming the data right here. So let's go ahead and do that. And I should see my uppercase Y right here, which is an array, and you have values of 0 and 1. So my B and M are changed into zeros and 1. Okay, so all ready for my neural network. I'm treating this as a binary neural network. That's why I'm changing them to zeros and one. But if you have a multi-case, obviously, and you're using a specific type of activation functions and all that, then you need to change that to categorical. For example, instead of loss, not activation, instead of binary cross entropy, you're using a different type of cross entropy, for example. Then it may require you to convert these values into categorical and not just integer encoded. If you have no clue what I was just talking about, then you're probably not ready for this lecture. Go back and get the basics as part of binary classification, multi-class classification, and so on. Okay. Okay, now moving on. So our Y is ready, and our X is basically every column except for these two, label and ID. Label we are using as Y, and ID, of course, is just useless for our purposes. So that is my X. And if you look up here, my X is still a data frame. It's not a NumPy array. So we need to convert our X into NumPy array pretty soon, but I just want to highlight that point. Okay, now before we do anything, let's go ahead and split our data into xtrain, xtest, ytrain, ytest. This is exactly what we do normally. By the way, this file, like I mentioned, is the normal way of doing your deep learning training, and then I'll show you a different way. Now, we need to scale the input values using min-max scaler, or you need to normalize the input values. And typically, again, I do this bad habit. I scale the values right here. I probably do min-max scaler right here and then split, but that actually leaks some of your information from the test data set into the training data set. So never do that. Always normalize the values or scale the values or handle or do the pre-processing step after the split. And that's exactly what we're going to do. First, we are splitting our X, our input, our entire data set into train and test. And in this example, I'm taking 25% as testing data set and remaining 75 as training. Now that it's split, I'm ready to apply min-max scaler to this data. And you know how to do that. From scikit-learn pre-processing, import your min-max scaler, you define a scalar object, and you fit the scalar object on the data, and then you transform respective data sets using this transformation function. So let's go ahead and scalar fit and scale the data. So now the data is transformed and it's pre-processed, it's ready. And of course, whatever steps I have just showed you, these are the steps that you need to do when you're doing your KFold, right? In KFold, if your K equals to 10, you're dividing this exact data into K different or 10 different batches. And for each batch, you have to scale or normalize your training and testing. So you need to incorporate that as part of your for loop if you're enumerating it manually, or cross-validation score. So let's look at that again in a few minutes. Okay, now that everything is scaled, what do we typically do? We define our model now. Again, this is a simple case model, but exactly the same process applies whether you're doing a complex unit or transformers time series. So any of those, although for time series, you're not dividing the data in a random way, because time means something. Your x-axis means something, right? So that's a different discussion. But in general, this is where you define your model. So I am defining one dense layer with 16 network units. And again, we'll tune these in the next video when we get there. But we're not thinking about tuning hyperparameters for a model. We are saying, okay, I have this model. How well does that model perform on my KFold cross-validation test? Okay, so I added a dropout, and this is my output. And since we're treating this as a binary classification, which it is, then the activation function is going to be sigmoid. So between 0 and 1, the values are going to be between 0 and 1. And the loss we're going to minimize is binary cross entropy using the Adam optimizer by tracking a metric called accuracy. Okay, all the basics covered there. And let's go ahead and look at the summary. Again, there you go. Okay, so it's pretty simple, pretty straightforward. We have only 500 parameters to tune, so a few seconds, fraction of a second per epoch, I would say. Now, how do you fit it? Okay, model.fit, you have your X and Y values, you have your number of epochs, you have your batch size, and you have your validation data as X test and Y test. Again, as part of your cross-validation, all of these need to be changed per fold. We'll get there. So this is our history. So let's go ahead and train it. And once the training is done, you evaluate the model. The training should be pretty fast. There you go. Evaluate the model. Model.evaluate. This is all the keras functions we are using, and 93.7% is the accuracy that we got. Okay, that's great. And let's go ahead and finish this off by plotting the curves. Again, this is customary, so I'm just showing you the normal way that we treat this this problem. So as you can see, I think it can use more epochs because it's still training right there, but okay, the accuracy is getting there. Probably I'll get even better accuracy if it's more than 20 epochs, but you got the point. Okay, and now you predicting the test set. So now you apply the same on your test set. I'm thresholding this above because sigmoid gives me a value, continuous value between 0 and 1. I'm saying, okay, anything above 0.5, it's something, it's one class. Anything below 0.5, it's a different class, right? So I'm manually setting a threshold. And now let's go ahead and look at our confusion matrix so we can see how well the model is performing. So 86 correct, 48 correct right here of malignant, and then we have 3 wrong and 6 wrong right there. So you can play with the threshold value to see like how the balance between these will look like. This is how we typically approach this problem. Okay, so after wasting 3 or 4 minutes of your time, now let's get to the actual part. And I hope you didn't find the previous part to be a waste of your time, because I hope there is always something to learn in these lectures. Okay, now let's clear everything. Let's clear this and let's clear our variables and start things from scratch. So let us clear the screen. Okay, now clean sheet. Now we are thinking in terms of cross-validation, KFold cross-validation. So let's go through the steps. These are all exactly the same. So you know what Python version, what scikit-learn, what TensorFlow version we are using, all of this. So let's get all the way down to X. Nothing, no difference, nothing all the way down to X. I did not scale these values yet. So this is X is still a data frame. Okay. And Y, we actually changed or encoded the labels from M and B to like 1 and 0. That's the only difference. Well, that not even a difference, but that's where we stopped. Okay, once we have our X and Y ready, now we need to think about KFold splits and how do we do that. So, well, ideally you would use cross-validation score, so you know exactly what the score is for all these scripts, for all these splits, which we'll do in a few minutes. But first, let's understand how we can manually enumerate through each fold. So first thing first, we need to define the KFold. Again, I hope you watched the last 2-3 videos, so you know exactly what I'm talking about here, right? So we need the KFold from our model selection. So let's import that. And now let's define a KFold cross-validation object with number of splits equals to 7. So we are dividing our 569 data points into 7 folds, and we are going to shuffle them before dividing it, and we are going to fix a random state by providing a seed of seed equals to 42. And this is our object. And now I have a cross-validation object, the KFold object. I need to use that object to do something. We'll get there. And I am going to go through each fold in a for loop, which means as we go through each fold, I want to go through a counter. So I know what fold number we're working on. So I initiate my counter right there. And then as we go through each fold, I want to capture the accuracy with that data using that model. So I initiated an empty list so I can populate it with the accuracy as we go through the for loop. Okay, now our X array, our X values right now is a data frame. A data frame cannot go into this keras model. So we need to convert that into a NumPy array. So that's exactly what we are doing right there, converting our array into NumPy array. So far, we haven't scaled these values yet, which we'll do in as part of the for loop, as the values are being split. Okay, so that brings up our min-max scaler. So let's go ahead and import that min-max scaler so we can apply that onto our data set. Okay, so for train and test set, within our cv.split basically provides you the indices for the training and test data sets. Again, we looked at this a couple of tutorials ago. So when I do cv.split and I provide like my x and y values right there, it says, okay, these are the indices for your training. These are the indices for your testing for each fold. So I need to go through the train and test for each fold and then do something with it. That's exactly what we are doing within the for loop. First thing first, we are scaling the values, and we are going to scale or train x. You see the train right there. This is nothing but the train indices. So we'll get all the x values corresponding to the training, all the x values corresponding to the testing, and we are going to fit the scalar, and we are going to transform the scalar on both test and train. So now you have your train x and test x data set, not just the indices. Yeah, so the train x and test x are the data sets, and train and test there are indices right there. So once you get your train x data set and test x data set, now is the time to train the model. But you need to define the model. Now, you can define the model outside of this for loop, which naively I did that initially. But what happens is when you define the model outside, the model is given a name like model 1, model 2, whatever the name it is, and the same model gets repeatedly trained as you go through update through the training process as part of your KFold down here. That doesn't mean much, right? I mean, you're basically providing the same data multiple times to the same model. Maybe that works if you have humongous amount of data and you want to train that model by giving your data in batches. And for batches, you're actually using the split, but that's not what we're trying to do. What we're trying to do is train our model on different splits of training and testing, and then evaluating how good the model is doing on the testing data set, right? So that's exactly what we're doing. This is why I'm reinitializing my model every time it goes through the for loop. Yeah, so that's why I have this in here. Hopefully that makes sense. And once we define the model, we are training it on our train data and our test data, and saving the model for each fold, and then evaluating. You don't need to save the model, but I am saving it here, and you can just evaluate on the test, on the test data for that specific fold. Go ahead and add that accuracy, whatever you get, to our list that we created, and update the fold number, and do this iteratively. And finally, I'm going to print the accuracy per fold, because we are capturing all of that as part of accuracy per fold right there. Okay, where did we stop? Min-max scalar, I think right there. So let's run the for loop all the way to here. This may take a little while. It's only 20 epochs, I guess, that we're doing per fold, but it's still 7 folds. So it will take some time, not a lot of time. Okay, so what is it saying? Apparently I did not run anything all the way from wherever we did or leave the last time. So let's actually go all the way down here and run these. So it was looking for fold number, and apparently I didn't run that line. So you'll see that, okay, this is your fold number 1, and it should be done anytime soon. So there you go. Now comes the fold number 2, and then it does that for 7 times. So let me pause the video only for a few seconds, and then let's go ahead and continue. Okay, so all 7 folds are done, and let's go ahead and look at one of these, probably the last one. So training for fold number 7, and you see how it started off with the accuracy of 62% and worked its way all the way up to 93, 94, 95%. That should be the case even for any other previous fold, right? So if I go back, it should be the same. So let me go back. Again, it started off around 60%, depending on the random initialization of weights. It starts around 60 to 65%, and it works its way all the way to 93, 94, 95%. So it's training the model. The reason I wanted to point that out is if you define the model outside of it, then every time it starts at 93, 95%, right? So, and then eventually at some point it's like, okay, 99%, and you get stuck there. That's why it's important to start from scratch. It's important to define the model inside the loop, so it gets initialized every time you run the for loop. Okay, so there you go. Now let's go ahead and print out the accuracy per fold. And let's see. So the first fold, the way the first data set was split and presented, the training data and the testing data were presented, we got an accuracy of 96.3%. And then on the different fold, 95.1, 88.9 on this fold, and so on. So as you can see, you can take a mean of all of these and standard deviation, and that gives you an idea of how well the model is performing on this data. So that gives you an idea of what to expect when real data gets thrown at this specific model. Now, one other experiment you can do is, okay, so this is fine. What happens if I change my number of dense units to something else? What happens if I add another layer to this? So what if it is not Adam but a different type of optimizer? And what if the dropout rate changes? So all of that comes into our hyperparameter tuning tutorial, which is the next one. So please stay tuned for that. But for now, I hope this makes sense. We split data 7 different ways, and we presented that to the training and then evaluation. So now we know the limit of our model. That's it. So KFold cross-validation gives you a great tool in understanding your model better, the limits of your model better, in evaluating your model. Now, you don't want to write all of this code. You just want to get this thing done with one line, and or maybe a couple of lines, fewer lines, let me put it that way. And instead of manually going through the entire for loop, let's clean this up. Yeah, nothing to show there, and let's clean this up. Let's just see how our good old cross-val score method is going to be used when it comes to our keras models. Okay, so I'm doing exactly the same I did in the previous file, all the way down to x. Now we have our y and x. Okay, no scaling, nothing yet. And now I want to introduce this amazing library right there. I mean, basically it's part of TensorFlow library, but KerasClassifier method that's available as part of TensorFlow.keras.wrappers.scikit-learn. Within that, you have KerasClassifier. So it's basically a wrapper that makes your keras trained model available for or keras model available for scikit-learn based tools. Again, TensorFlow is a very dynamic library. It changes all the time, so I cannot guarantee that you'll find this exact method in one of the future upcoming TensorFlow releases, but I'd be shocked if they remove this completely. They may repackage this in some other folder, yeah, but hopefully it's available. Okay, so let's go ahead and import this KerasClassifier. I have it right there, and now I'm defining my model. Now you don't have to define your model in the for loop because there is no for loop, yeah, that we are deliberately writing. But we need to provide this model into a method later on, so it does its own for loop. We don't have to write that. Okay, so our model is, I'm creating our model as a function, so that can be provided as input. Nothing different, exactly the same function that we have done, exactly the same model that we defined earlier, except in this case, it's in the form of a function. That's it. Okay, now we need to create a model. So I'm calling this my keras model is KerasClassifier right there. That's what we are using. And what function do you want to use to build this? So my build function equals to create model. This model, so it creates that model. So this is how the KerasClassifier is working. So let me bring this down so you can see exactly everything right there. So and KerasClassifier, again, we are trying to train it for 20 epochs with a batch size of 16, and don't print anything on the screen because it makes things a bit slow when you print it. So this is my keras model that I defined. Still, we are not running it yet. We're not fitting it yet. We'll fit that as part of our cross-validation score. Okay, now comes our KFold, cross-val score, NumPy, and pipeline is the important part. Again, I touched upon this in the last video. You provide, instead of providing a model as an input, you can provide a pipeline as an input to your cross-val score. So that's why we are importing this pipeline, and we'll create a pipeline in a second. Okay. So let's run these lines. Good. And now let's define min-max scaler. Again, you have to do that as part of your deep learning training, or even regular machine learning training of structured data or even image-based data. You just divide image-based data by 255, but especially for structured data where you can have each feature or attribute come in different ranges, bring everything into one common minimum and maximum limits. Okay, so our now that we imported our min-max scaler, let's create a pipeline that includes scaling, that also includes the model. Again, we did this in the last video, so I am creating a list because this list of steps is going to be provided as input to your pipeline. So let's create a list, and the first step as part of our list is defining a scaler. So I'm defining my scaler, min-max scaler right there, and then I'll define my model right here, which is nothing but my keras model that we defined, and my pipeline is defined as pipeline steps equals to steps, these steps right there. And if you look at the pipeline here, you see that this is a pipeline object, right? So this is not just any other regular variable, this is a pipeline object, and steps is nothing but a list. And when I open the steps, you should hopefully see it. Did I open? Yeah. So you see that my steps actually has two tuples. The first one is a tuple that's a scalar and defines what that scalar is, model, what the model is. Okay. So that is our pipeline. And now we are all set to define our cross validation. So our cross validation in the previous file, we have used these parameters. So let's go ahead and use exactly the same. Number of splits equals to 7. Random state is 42. Shuffle equals to true. This is my cross validation object. And this object is provided as input to your cross-val score, which is doing all the job for us. So all the for loop and everything that we did manually, that's exactly is taken care of our cross-val score. The input is a pipeline that contains all the steps that's required, and the data, X and Y. I'm not scaling the data. The scaling happens as part of the pipeline. As you can see, the min-max scaler is right there. My scoring that I want to track as this is happening is accuracy. The cross-validation I would like to use, you can just give a cross-validation number equals to 3 right there. But then it uses all the other parameters as default, but we manually defined what cross-validation type we need, and that is provided as an input here. And number of jobs equals to, I put number of jobs equal to 1. If you put number of jobs equals to -1, it tries to suck all the resources you have, and it may crawl so slow. So just define based on your hardware. Okay, so where did we leave off? And this is my score. Let's go ahead and run this. And this is where it kind of takes, again, a few seconds to minutes. So I'm going to pause this video until that thing is done, and let's continue. Okay, and a few seconds later, it's done. And now let's go ahead and print the scores, right? Because we captured everything as part of scores right here. And scores is basically an array of length, how many ever folds you have, and it captures all the scores in there. So let's go ahead and print one by one. So you can see for the split is 98.8, 95.1, 94, 90%, 92, 87, 93. It should be very similar to what we got earlier when we manually evaluated it. So there you go. And again, if you want, okay, an overall metric that defines how good your model is performing, then I can say, okay, 93.1 on a cross validation equals to 7. So that's how good the model is performing. Okay, I think this went a bit longer than I wanted, but I didn't want to leave anything for your imagination. So I appreciate your patience when you're listening through some of the concepts that you think are basic, but there are a lot of newcomers who are watching this video, so they may find some of these aspects to be very useful. Okay, in the next video, let's go ahead and use a similar concept to train or tune our hyperparameters as part of I'm searching for words, as part of our keras neural network right here. Thank you very much, and again, do not forget to hit the subscribe button.